All right, guys. So here are the formulas. So I'm going to slap up here a bunch of formulas. I'm open to suggestions of other things you think should be on there, besides what I put down up here. I think you're working. Let's find out. So, of course, chapter 1 was definitions. It was crazy exciting. So awesome to go through that. They should make it a ride. Disney World. No, the terminology, yeah. Our first real formula. So something like class width, you have to know. I'm not going to let you write it down. So that's one you have to know. How do you calculate class width for a histogram? I heard it. Range divided by number of classes. And again, there's a physical idea behind that formula. So formulas aren't themselves things to memorize. The more important thing to think is the idea behind a formula. Okay. So the real first equation that you might not even want to write down, but is up to you, is this guy. And that's the formula for what? Be more specific. Because what's the other formula for mean? It has a what here? Yeah, this is population mean, sample mean. Notice how I'm not writing the word population here, because you can't. If you do, you lose points. Right? These are the same formula. They're just for two different things, right? Two different groups. I like it. So then next to it you could have, what's this one? Who to what? Yeah. Variance. I like it. Because I haven't taken a square root yet. So this is the one where you add up all the square distances and divide by how many there are. So if I ever see a formula that sum of something divided by how many, that's the average that thing. Because how do you average anything? Add them all up, divide by how many there are. So what's the idea behind the variance? It's the average square distance from the mean to the data points. That's what it is. And of course, then I have to do what to make it make real sense? I don't care about square distances. I want the average distance, so then I can square root it. You don't have to have both of these formulas down there, but you can if you want to. See how they're both the same formula, right? Did you guys see that? All right. You want to be nice to yourself on your formula sheet. Put things down that'll make the most sense to you. Okay, I like it. And of course, what letter do I use for a sample, standard deviation and variance? S. For a little sample, they get R letters. For a population, they get Greek letters. Looks neat, right? Sort of like Super Bowl, Roman numerals, same idea. Okay, I like it. So it's the same formula except a couple things. What goes here? Because it's a sample standard variance, so what goes here? Yeah, not mu, it'll be X bar. Why is there a mu there? Because it's a population. Why is there an X bar there? Because it's a sample. And I'm going to divide by what? What's the difference between these two? I like it. And of course, then if you want to, you can put down S equals big S square root. So that little n minus 1 is an adjustment because it's just a poor little sample. Okay, maybe. Oh, let's see. And then, what else, Jeff? Was there anything else? I think that's it. Let's put this down if you want to. I'm not going to ask this question explicitly, but I'm pretty sure I told you guys that this formula that was on that standard deviation sheet we did, that's the z-score, the number of standard deviations from the mean to a data point. So just a real quick word about that. Am I going to use inches to talk about the distance from the sun to the next star? No, right? Right? Why? Because stars are so, you could say it, please say the magic word. Stars are so spread out. Right? You guys all right? All right, back here somehow. Stars are so freaking spread out, so I'm not going to use inches. What about distances between people in this room? Could I use inches? To talk about distances between people in this room. Would that make more sense? Hell yeah. Why? Because people in this room are not so spread out, right? Thankfully. That would be really, this next star over. Get the idea. All right. Now, so what the hell's that got to do with shit, right? I'm like, okay, stars, us, great. Standard deviation measures spread. So that's why it makes sense to use. Standard deviation are like using inches versus light years. Standard deviation are the tick marks on a ruler. When I calculate a z-score, I'm seeing how many standard deviations are between two things. I'm taking a measurement then. Standard deviation itself sets up how far apart the tick marks are. Z-score is when I take a measurement to see how far apart things are. So how do we measure distance in statistics? Is z-scores. All right. So for example, anybody have anything else they want to add? I think that should be everything. Anything you think I missed? I'm open to suggestions. Okay, so that's it. If you have any more than this on your formula sheet, you will lose points. Right? And throughout the semester, when we make new formula sheets for more tests, you can just keep on adding to it or bring in all your formula sheets. You can bring in a mountain of formula sheets as long as none of it has more than what I said could be on it, and you don't disrupt anybody near you. So what's normally true about formula sheets? Don't they normally, have you guys ever had that one where you have to be a 3x5 card? And I'm like, on a grain of rice, you can put all the notes you want to, right? That's bullshit. So just, if I let you take notes or use something on the test, use as much freaking paper as you want to. Just don't have more than I say you can have. Okay, like it? Okay. Has everybody got all this? All right. And if you don't, yes you do, because I just recorded it. If I turn it on. Did I turn it on? You think so? I love it. You're like, walk over there, math boy. Take a look. Oh, good. Okay. All right, guys. So, quick example of what I just said. So there's some problems in the homework that say this, and I'm almost certain that some of us haven't made it. There's in section 2.7. They give me a mean. Let's say the mean is 111.2, and they give me a standard deviation. And then they say what value is 2 standard deviations below the mean. Some of you done that homework yet? Have you seen that problem yet? All right, I like it. That's where some of you have, and some of you go, I'm just going to shake my head yes, so who thinks I'm that far at home? How do I do this? How big is each standard deviation? I don't just add 2 to the mean. That doesn't make any sense. What am I going to add to the, or I'm sorry, I'm not going to add to it, am I? It's supposed to be below the mean, so I'm going to subtract something. How much am I going to subtract? How big is each standard deviation? 17.9. So I'm going to subtract 2 of those. So I'm going to take the mean and subtract 2 of these. All right? It's that simple. So that's why I say in your head you can replace the word standard deviation with step. If I take 2 steps below the mean, and every step is this big, where do I end up? All right, well, that's a physical problem now. You can actually kind of see how the math makes physical sense. So whatever the shit that is, right? What the shit is that? 75 something? Let's see. You're gonna make me do it in my head, aren't you? 75.4. That was pretty close, sorry. Right. Okay, maybe. So watch this. What if I had, the mean was 111.2 and the standard deviation was 1.93. Now what value is 2 standard deviations below the mean? Maybe got it? Is the work different? No. Still 111.2 minus 2 what's? 1.93s. Because now the spread is different, right? So tell me which, and then whatever the hell that is, what is that? 108, 107 point? Sorry? 107.8? Who? 3-4? It almost doesn't matter. Those are both 2 steps away. Those are both a z-score of -2. What the shit did I just say? Well, a z-score tells you the number of standard deviations away from the mean. These are both 2 steps below the mean. Why is that one so much bigger than that one? Because this step size was bigger. So which one of these data sets are more spread out? The first one or the second one? Which one's more spread out? How do you know? Standard deviation is bigger. Standard deviation measures spread, right? You guys with me? So of course the first one's bigger because the standard deviation is bigger. It measures the spread. So the first one's more spread out, right? So it's going to look more like it's going to look like a whoa, right? Whatever the shit. If it was normal, let's say, right? And this would be 111.2. Boop, boop, boop. So if I take 2 steps in this data, I'm going to end up way the shit down to 75.4. Here, is this really spread out at all? No, right? It's like, what is that? It's like 9 times less spread out. So this picture might look more like this. Much less spread out. So if I take 2 steps down, I just end up at 107.34. So it's maybe even more than that, Jeff. Wow. It's really tight to the middle. It's not spread out much compared to this guy. Okay, maybe. I don't know if you've picked up on this yet, but statistics is not the same as another math course you've taken, and the fact that the ideas are even more important than before, right? Formulas are almost just at the same level as ideas, whereas in algebra, you can get away with knowing the formulas and not really getting the idea too much. But still, the more you know the idea, the easier. But in statistics, holy shit. It's a lot more important to get the idea of something down. Okay, maybe. Okay. So, now I've gotten my stuff out. I don't normally have this day structured too much because it really depends on what kind of questions you guys have, if any. Question, yes?
How do you do it when, okay, so this is saying like it's 2 standard deviations below, so you just subtract it twice, but you know when it's like worded differently?
Like, can you give me an example?
No.
Shit, all right, well.
It's like you're looking for like, does anybody know what I mean?
So the problem in the homework, right?
Yeah.
And they ask you this kind of question. Let's take a look at the homework for section 2.7. There you are. So that's there. So, I mean, here's the kind of questions they gave. There was the one about the musical instruments and which one was relatively better. Which one was relatively lower cost? I don't know if you guys have done that problem yet. Then there was one about the people running in their classes, and which one was the better runner, right? Those aren't this. Exactly. Help me out here. Now watch. Just go. What was this? What idea was 111.2? That was the mean. 2 was the number of steps away I wanted to go. And that's Z. Z measures how many steps from the mean you are. And what was this? Standard deviation. And we ended up with a data value. Right? And really, 2 standard deviations below means the z-score was negative. So if I make the formula this, and the z-score, why is the z-score negative? Because I am below the mean. So if on the quiz, you got a score that was below the mean, your z-score is negative. Because you're so many steps below the mean. If you got a score above the mean, you got a positive z-score. I like it. Okay. So, now watch. Watch. Z-score formula is this. Let me do an example of this, and let me show you how those are tied together. Did we even know that formula before we did this problem? No, we didn't. I love you guys. Some of you guys know. No, we just made that freaking formula, and we just did a couple problems like this, didn't we? So a weird thing you will almost never hear a math person say, but it's reality, is the formula is secondary to VIT. I think I've already said that. We will create a formula so we can communicate the idea very effectively. Bam! Right? There's the idea. There it is. I don't have to use a lot of words. I can just show you a lot of symbols. You with me? But a lot of us don't speak mathish that good. Right? Yes? No? So then that's why we have to kind of make it into English. What the hell is the idea behind this thing in English, Jeff? Okay, maybe. So in the book, they'll say something like this. Let's say that class 1 had a mean grade on its test of 80 and a standard deviation of 11. Class 2 had a mean score of 62 and a standard deviation of 14. Cool? Yes? No? I mean, of course it's good. There, it's just a bunch of data I gave you, right? So here's a question. If Bob is in class 1, and they made a 86. Meg is in class 2, and she made a 78. Who did relatively better? So you can't just look at 86 and say, that's bigger than 78. So Bob did better. That might not be true. Who did relatively better? Why is the 86 not necessarily better than the 78? Are they both above average in their own classes? Yes. How much above average is Bob? 6 points, but that's not good enough. I really want you guys to realize, because the standard deviation is different. So 6 is, I can't just say 6 and that's it. I got to figure out what the relative, but he is 6 better than his own average. Meg is 16 better than her own average. But that doesn't tell me, well, how important is 6 and 16 in those classes? Depends on how big the step size is. How big is the spread? If it's really spread out, then if you're 6 away, who gives a shit? But if it's really not spread out at all and you're 6 away, holy shit, that's big. So for example, if every step size was 2, how many steps would it take to go 6? If every step size is 2, how many steps would it take to go 6? 3. right? 3 steps, 2, 4, 6. All right. If every step size is 1, how many steps do I take to go 6? 6 steps. So that distance of 6 doesn't by itself tell me anything. I have to know how big each step is. Okay, so what I do for each case then is I calculate a z-score. What's Bob's z-score? Well, it's going to be this. What's his score? 86. Minus his class's mean, divided by their spread. Was I 0.54 forever, maybe? Who's going to help me out? I think it's about 54%. And then what's Meg's z-score? Don't get 54%, Jeff. Stop that. 0.545, right? Is that cool? Somebody can help me out? Yes? And then Meg's would be 78. Lower score than Bob, but he's in this other class where everybody did great. 78 minus 62 divided by 14. 16 divided by 14 is 1.14. So Bob got a little more than half a step up from his mean. Meg got more than a step up from her mean. So who did relatively better? Meg did. Okay, maybe. Sort of like, did I tell you the story about my first test I took in grad school, and the teacher gave it to me, and I got like, what was it? It was like 20 out of 42 right. And I thought, what am I doing here? I don't belong here. Right? And then the teacher, after he gave it to me, he's like, good job, Jeff. I'm like, is he being sarcastic? But then come to find out that the average on the thing was like 17, you know. So relative to how the class did, I did well. But by itself, if I told you, oh yeah, I got a 48% on my, it's like, I'm sorry, dude. It's like, no, it's all good. It was like one of the higher grades. This number tells me all that shit immediately. What'd you make on your test? I got a z-score of 2. Holy shit, that's amazing. What could the grade itself be? The grade itself could have been a 40. If everybody like died on that thing, and that's what they love to do is in grad school, they give us a test. Like I think people average about a 30. So if you make a 40, it's like, ooh, good job. And then they curve the shit out of everything, right? That's basically grad school. So they kind of scare the shit out of you, and they're like, that's not that bad, all good. All right, maybe? No? Do you guys get this? I can't tell just by looking at these numbers. Because obviously we would have said Bob did better. But his test was easier maybe. So it's not fair. Okay, maybe. Anything else does that make more sense? I mean, I think some of the problems in the homework are more like that, where they give you 2 different things, 2 different classes with 2 different means, 2 different standard deviations. You have to calculate the z-score to really be able to compare who's better, who's worse. So what if somebody got a z-score of negative 1.4 and somebody else got a z-score of a negative 1.1? Who did relatively better? This is a test. No, I don't mean this is a test, but on a test, they got those z-scores. Who did relatively better? The first one or the second one? First one. What does this mean? His score was what? 1.4. 1.4 watts below what? 1.4 watts. Standard deviations below the mean of his class, right? This other person, his score was only 1.1. Did either one of them do well? No. But who did better? Second one. Because it wasn't as far down as the first one. It's only 1.1 steps down instead of 1.4 steps down. They both did worse than average, but the second dude didn't do as bad because it's not as far down. Yes? I like that reaction. Everybody must do that when you get something. Is that better? I don't know if that really, is that to your, because I think that's the other kind of question they ask, is either using this idea or this idea. They got those two in there. Okay. So you know I'm going to have both of those things on the test. Okay. Anything else you want to look at? We could do examples of problems. Yes?
Are you allowed to go over the quiz?
Yeah, you can ask questions from any damn thing. Probably statistics related is better. Oh, all right. So, all right. This one always kind of kills me a little bit. What must the sample be? What kind of thing is a sample? It's a what? Subgroup. A subgroup that we hopefully did what to get? I love that. I'm no good at charades. Ready? First word. Sorry. A subgroup that, how do we get them? We hopefully did what was the magic word to make it a really good sample? Randomly selected the people, right? Okay. So if I say to you, now watch this. If I said, I go pick 80 Grossmont students, what's my sample? 80 Grossmont students. What's my population? All. So some of you guys, I said which on your population. Use the word all. Because if I said, now listen to me. If I said, next door there are bikers versus next door there are all the bikers. Is that a different idea? Yeah. Okay, so if you're saying the population, use the word all or some variation of that. Because if you just say doctors, I'm going to say which, and you use points. Which doctors? Doctors are next door versus all the doctors are next. Holy shit. How did we do that? All right, coming back to the sample. So, going with this, 80 Grossmont students. That's my sample, right? Does my sample change if I go ask them questions? I got 80 Grossmont students in a room, and I go start to ask them questions. Does my sample change because I'm asking a question? No. They give me answers. Does my sample change? No. I calculate a percentage of people that said something. Does my sample change? So let me ask you this question. What's the sample and population here? 7% of the 80 Grossmont students I talked to enjoy broccoli. No. What's my sample? No. If you say your sample is 7%, then how did you randomly pick the people that like broccoli? That's what you're saying. If you say your sample is the 7% that like broccoli, you randomly picked the people that like broccoli, and that's more like a psychic demonstration or something. I can sense when people like broccoli. Please understand what I'm saying. How the shit can you say that the 7% you calculated after you got your sample is suddenly what the sample is? What's my sample? The people I talked to. What do I do once I talk to them? Don't I calculate shit? The average height and the percentage of people that wear Nikes, and right? You guys with me? So if I say 28% of the 3,000 people I talked to wear Nikes, 3,000 people is my sample. What's the 27%, whatever it says? That's the statistic. That's something else. That's what I did with the data. Maybe. Okay. Here's the awesome thing about it. You ready? Normally you can tell what the sample is on most problems pretty quickly, right? Yeah. So when I said like 3,000 people, yes?
Would the sample be the 143?
Everybody had a different version of the quiz, so I'm not going to answer anything specific. But
like the number of
yes. Now watch this. You ready? Yeah. So if your sample was 1,500 German Shepherds, what's your population? All. So replace the number. This almost always works. Replace the number with the word all. Because where did I select the 3,000 German Shepherds? I don't remember how many German Shepherds I said. Where did I select the German Shepherds from? All German Shepherds, right? And if I didn't, I should have been more specific. What if I say my sample is 3,000 German Shepherds from Wisconsin? What's my population?
All German Shepherds in Wisconsin.
All German Shepherds in Wisconsin. So it's very often it's easier to get the sample, and then you just change the number to the word all, because that's where they must have come from. What's the connection between sample and population? Sample came from the population. So that's why they're going to sound exactly the same, just one is going to be more specific group and the other is going to be everybody. I like it. See, that is a good question. And this is why I let the quiz grade change so much, is because a quiz is sort of a gauge of where you were. You're a different place now, you can get a better grade for that. I try to make my grades dynamic instead of static. Changing as you learn more shit instead of set in stone forever and too bad. Okay, how are we doing with that? Is that? So a lot of people, trust me, on that first problem thought that the percentage was the sample, but that doesn't make any sense. How could I have randomly selected those people? That is amazing, right?
Wait, just to clarify, so it will be like all German Shepherds, and then the sample will be like 12.
Sure, 12 German Shepherds, exactly. Sure, yeah. Well, for the first problem, does the percentage I give you mean shit? Well, I pretty much gave the answer away in my question, but no, it don't mean shit. Because they didn't ask what's the statistic. That is the statistic. That's what I did with my sample. Same kind of thing happens later when I say like 20% had a Ford, and 30% had a Chevy, and 10% had a bike, right? The percentages don't mean shit. What was the question I was asking people? But in that problem I just gave, 30% had a Chevy, 20% had a Ford, 10% had a bike, comma, ... So there were more. What was I asking people? Take the bike out. 20% had a Chevy, 30% had a Ford, 10% had a Hyundai, 2% had a Kia. What question was I asking people? What question was it? Do you know what those words are? Yes. What am I asking people? Huh? No. I'm not saying, hey, what's the mode? When I get a list, when I say 20% had Chevys, 30% had Fords, 10% had Hyundais, how the hell did I get there? What am I asking people? What kind of car do you drive? Okay, what level?